Hello everyone, welcome to my channel. My name is Navneet Kumar and I'm a student of Sri Venkateswara College of Engineering. And this is another video assignment of mine. And here we are going to discuss about the topic which is volume by triple integration and center of gravity. So let's move on to our topic, introduction. In this video we are going to discuss or understand about the concept of volume of triple integration, and we are also going to deal with center of gravity. So everyone will ask what is volume of triple integration, right? So till now we have dealt with integrating over a two-dimensional region, right? Now we will move on to this integrating over three-dimensional region. So in double integration we always use two-dimensional region, right? Like XY plane, the limits are given to us. We just apply the formula substitution and do it. So it shouldn't be too surprising, right, that we'll use a triple integral to integrate over a three-dimensional region, right? So to understand it, it's very easy when we are dealing with it. So when we are talking about Cartesian coordinates, right? When we are doing this triple integration, in case of doing it with two variable limits of x, y, we take add another variable which is z, and we do it step by step, right? We will have three, uh, like in case we can see this three integrational symbol, right? So first we'll differentiate this del v with respect to x, then with respect to y, and then with respect to z. So we have to do it step by step. So when we are talking about Cartesian coordinates, here for a region R in x, y, z space, the volume can be expressed in the, as we call it, this del v term. So by defining the limits of integration for x, y and z based on the region R, and we will integrate over the specified limits to find the volume, right? Next we have how do we do it when it comes to like cylindrical and rational symmetry, right? So we have to first transform it to the cylindrical coordinates, which is rho, phi and z, and adjust the differential volume element. Then we have to determine the limits of the given coordinates, and then again integrate it step by step, right? Next we have suitable coordinates for our spherical symmetry. So here what we'll do is here we'll transform it into phi, theta and rho, and then we will modify the differential volume element step by step and calculate the volume, right? So the next topic is about application of triple integrals. Where do we apply it? So when we talk about physics and engineering, we use this triple integration to calculate the volume of irregular shaped objects. So we have to determine the mass distribution and analyzing physical systems, right? The volume of the object is also measured here. So this is where it is applied. And when we are talking about electromagnetics, we analyze the magnetic field and their interaction with the objects of varying shape. So this is how where we apply our triple integration. Now, our second topic of the day, main topic, which is center of gravity. So when we are talking about center of gravity, let's deal about two-dimensional objects. So for a continuous object in the xy plane, the center of gravity is calculated using a double integral x of is equal to 1 by a with the double integral x of dA, and dash, which is 1 divided by a double integral y of dA. So what is a here? A is the area of the object, and this is the formula for it, right? So when we are talking about center of gravity, that formula was for two-dimensional okay, objects, and this one is three-dimensional objects. So what is the formula for this? So for a continuous object in xyz space, the center of gravity xyz is calculated using triple integrals, obviously. So x, how do we calculate it? 1 by v triple integrals of x dv, and y is 1 by v of triple integrals y of dv, and z is equal to 1 by v triple integrals of z of dv. So here the v is volume of the object, right? In the 2D, it A was the area of the object. In 3D, when we are dealing with it, we will talk about volume of the object, right? So next topic under this main topic is what is applications, or where do we apply the center of gravity, right? So it is used in structural engineering, right? So balancing and stability of analysis of structures, right? Like we are, I think chemical engineers use it a lot, right? They check the stability, they analyze and balancing everything they do when they are dealing with the creation of structures, right? And of course, many of us are interested in automobiles and everything. So automotive industry, which deals with designing vehicles for optimal weight distribution, right? So even they use it. So center of gravity is very important. In fact, one of the major thing, like which is dealing with our sky, which is aerospace. So we have to determine the balance and stability of aircraft, right? You know how it is so fast to just travel in this airplane, right? But we have to make sure our safety. So this is how it helps in our application of center of gravity. So yeah, aerospace is also one part of it. So with this, I would like to thank you guys for watching my video. If you liked it, please give it a comment, share, like, subscribe. Okay. If you have any doubts or if you want to comment anything, say to me. Please comment it down. Okay. Thank you for watching my video. See you again. Bye.